An unsymmetrical parabolic curve has a forward tangent of negative 8% and a back tangent of positive 5%. The length of the curve on the left side is 40 meters long, while that of the right side is 60 meters long. The PVC is at station 6 plus 780 and has an elevation of 110 meters. A box culvert whose width is 2 meters and has a height of 2.5 meters is to be constructed at station 6 plus 800 being its center line, whose top elevation is 108.40 meters. Compute the height of the fill at the left edge of box culvert. Compute the height of the fill at the right edge of box culvert. Solve for the stationing of the highest point of the curve and solve for the elevation of the highest point of the curve. So, in order to answer the problem correctly, we have to illustrate the problem by drawing the correct figure. So we have here a forward tangent of negative 8%. So this is our forward tangent, negative 8%, and the back tangent of positive 5%. So here's the back tangent of positive 5%. Now, the length of the curve on the left side is 40 meters long, while that of the right side is 60 meters. So, this is the curve. So, the length of the left side is 40 meters, while that of the right side is 60 meters. So these are PVC, PVI, and PVT. PVC is at station 6 plus 780. So we have PVC at station 6 plus 780 and an elevation of 110 meters. A box culvert whose width is 2 meters and has a height of 2.5 meters is to be constructed at station 6 plus 800. So if this is 6 plus 780, we add 20 meters here. So this is 6 plus 800. Being its center line, whose top elevation is 108.4. So here's our box culvert. So 6 plus 800 is the center line. So this is 2.5. This is 1 meter. This is 1 meter. And top elevation is 108.4. So this is our top elevation, 108.4 meters. So after constructing the figure, so we will try to determine what is required. For number 1, the height of the fill at the left edge of the box culvert. So this is the left edge. So we are about to compute this height. Let's call this D1. Number 2, so we are to compute D1. Compute the height of the fill at the right edge of box culvert. So this is D2. Solve for the stationing of the highest point of the curve. So we still don't know yet where the highest point is and also the elevation, but we are going to find out when we solve number 3 and 4. Now let's try to focus on, let's start solving with number 1. Compute the height of the fill at the left edge of the box culvert. So if this is your culvert, let's get, this is your culvert, so this is your H, or the vertical offset, PVI. This is your culvert. So for number 1, this is your PVC. So we are about to solve this D1. So in order to solve for D1, we have first to solve for the elevation of this point. Let's call this point A. So we have given elevation of PVC of 110 meters. We have D1 is equal to elevation of A minus the top elevation of 108.4 meters. Now, how are we going to solve for the elevation of A? If you would take a look at the figure, we have a given elevation at PVC. We can solve this height. Let's call this H1 with H in lowercase, and let's call this height Y1. Now it will become D1 equals, for the elevation of A, we have elevation of PVC plus H1 minus Y1. So this will be your elevation of A minus 108.4. So how are we going to solve for Y1? We will use the square property of parabola, wherein y1 is to x1 squared equals h is to l1 squared. So your L1 here is equal to 40, while your X1 is this distance from PVC up to here, this stationing. So you have here 19 meters. This is your X1. Then we solve for the value of h using the formula that we derived. We have h is equal to G1 minus G2 multiplied by L1, L2 over 2 times the quantity of L1 plus L2. So by substitution, we have h equals G1 is positive 5% minus negative 8 or 0.08 multiplied by L1 of 40 and L2 60 over 2 times 40 plus 60. So we have h equals So we have 0.05, so minus, it will become addition 0.08 times L1 times L2 over 2 times L1 plus L2. We have H of 1.56. Now, in order to solve for the value of y1, we have y1 is to 19 squared, using the square property of parabola, equals h is to L1 squared. So the value of your y1 is equal to 1.56 times 19 squared over 40 squared. Now we have 0.35. Then let's solve for the value of h1. So we have h1 equals, so in order to solve for the value of h1, or this height, just multiply the distance from PVC to point A, the horizontal distance, multiplied by the grade. So we have h1 equals 19 multiplied by 0.05. So we have h1 equals, so we have 19 times 0.05. h1 is equal to 0.95 meters. Now we already solved for the values of y1 and h1. We already have elevation of PVC. Now it's time to substitute. So we have d1 equals, elevation of PVC is 110 plus h1, we have 0.95 minus y1 of 0.35 minus 108.4. We have 110 plus 0.95 minus 0.35 minus 108.4. We have 2.2 meters. So the answer for letter A, we have D1 equals 2.2 meters. And that answers question number 1. Now, in order to solve for the height of the fill at the right edge of the box culvert, so for number 2, so again, this is half the curve. We have PVI, PVC, H, which is 1.56. We have here the grade of 5%. This is 6 plus 800, so this is 20 meters. This is 1 meter. So we are to solve for D2. So in order to solve for the value of D2, we have to subtract the elevation of this point on the curve, let's call this point B. So D2 equals elevation at B minus this elevation of 108.4 meters. So we have PVC elevation 110. So now how are we going to solve for elevation at B? So if we project this line here, this height, let's call this H2, and this is your Y2. So just like what we have done in number 1, so let's follow the pattern. So we have D2 equals elevation of PVC plus H2. So we will arrive here minus Y2. So that is the elevation at B minus 108.4. Now we have elevation of PVC. So what are we going to look for is H2 and Y2. So we have H2. So this height can be solved by multiplying the distance. So we have the distance here, 20 plus 1, we have 21 meters. So 21 times the grade of 5%, which is equal to 1.05 meters. Then we solve for the value of y2 using the square property of parabola. So y2 is to x2, so 21 is the value for x2. So 21 squared is to h 1.56 is to L1 of 40 squared y, so equals 1.56 times 21 squared over 40 squared. So we have y2 equals 0.43 meters. Now, having h2, y2 elevation of PVC, we can solve for d2. d2 is equal to elevation of PVC 110 plus h2 minus y2 minus 108.4 meters, or the top elevation of the box culvert. So D2 is equal to 110 minus 1.05 minus 0.43 minus 108.4. So we have again 110, so this must be at, we have 2.22 meters. That's the value of your D2. Next, let's try to solve let number 3. Solve for the stationing of the highest point on the curve. So let's assume our highest point to be located here, point C. Or maybe let's redraw the figure. So number 3. PVC, PVI, PVT, H 40, 60, 110, 6 plus 7, 80, 5%, 8%. So now, knowing that we have here 5% and this is negative 8%, so let's assume we have the highest point here. Let's call this point C. Okay, so let's check L1 G1 over 2. So that is equal to 40 times 0.05 over 2. So that is equal to 40 times 0.05 over 2. We have 1. And it must be less than h of 1.56. Therefore, use S1 equals G1 L1 squared over 2h. So by substitution, we have S1 equals G1 L1 squared over 2h. So we have the G1 L1 squared over 2h, and that is equal to 25.64 meters. Therefore, from PVC, therefore we add